Finished? Is it done, students? Arshita, is it over? Written? Arshit?
Sir.
Varda?
Varda, sir.
Okay, we'll solve the problem. First, you go through it once. The pre-stressed concrete beam of section 120 mm wide and 300 mm deep. The sectional dimensions are given. Used over an effective span is given, and UDL over the beam is given, which is inclusive of sulfate. Okay, no need to separately find the sulfate. Okay, whatever the load which is given, it is inclusive of sulfate. Okay. The beam is pre-stressed by a straight cable carrying a force of 180 kilonewton. Okay, 180 kilonewton and located at an eccentricity of 50 mm. It's a straight cable located at an eccentricity of 50 mm from the neutral axis. Okay, determine the location of thrust line in the beam and plot its position at quarter and central span. Okay, now with respect to this condition, we have to locate the location of the thrust line at quarter span, support, as well as at center of the span. Okay, now to locate that thrust line point, okay, we have the formula. Okay, we have the formula, that is E is equal to M by P. Okay, this formula you remember, all of you remember, E bar is equal to M by P. Okay, and this equation is applicable only for straight cables. If it is a parabolic cable, the procedure is different. That I will tell you in the last problem. Okay, only for straight line. Only if the straight line is given, then only this formula is applicable. Otherwise, you have to follow different procedure. Okay, E bar is equal to M by P. Okay, where M is moment at the point of interest. Okay, if you are locating a pressure line at support, you have to take moment at support. If you are locating a pressure line at mid span, you have to take corresponding moment at the mid span. Similarly at the quarter span. Okay, this P remains the same. Okay, pressure what is pre-stressing force remains the same. Okay, now write the given data. P is equal to, second problem, P is equal to how much it is given? It is given as 180 kilonewton. P is equal to 180 kilonewton. 180 kilonewton. Then dead load of the beam. Just a minute, students. What is the exclusive? No. Exclusive of sulfate. Sorry, I did not see it properly. It is not inclusive. It is exclusive of sulfate. You have to find it. You have to find the sulfate separately. Then you have to add it to the live load thing. Okay, I did not say it properly. It is exclusive of self-weight. Now you have to find you find the self-weight on the beam, dead load on the beam. Dead load of the beam is equal to dead load of beam is equal to WG is equal to cross sectional area is how much? It is given as 120 mm by 300 mm, right? So it becomes 0.12 into 0.13. Density is known, it is 24 always. 0.864 kilonewton per meter. Am I right? Dead load of the beam.
Sir, it's 0.12 into 0.3.
Sorry, 0.3. I'll make it 0. 0.3. Okay. Now dead load is 0.864. Live load is given, that is 4 kilonewton per meter. The total UDL on the beam becomes how much? Therefore, the total load UDL is equal to 4 plus 0.864, which is 4.864 kilonewton per meter. Okay. Now we have the formula to look at the thrust line. E is equal to m by p. Okay. E is equal to m by p. First, where m is the moment at point of interest. Here it is asked to locate the thrust line at support, quarter span, and center span. First, what we will do is we will find moment, corresponding moment at support, mid span, as well as quarter span. Okay. Write the diagram. So beam which is acted upon by a total UDL of 4.864 kilonewton per meter. Okay. What is the total length of the beam given?
6 meter.
Okay, 6 meter. Total length of the beam 6 meter. Okay. Now we have to look at the thrust line at quarter span and at center span. Quarter span means total 6 meter, it becomes 1.5 meter. 1.5 meter and mid span is 3 meter. 3 meter. Okay, first you find the reactions at the supports. WL by 2.
Sir, how it is 1.5 and 3 meter?
See, in the question, they have asked to locate the thrust line at quarter span and central span. Okay, quarter span and central span. So quarter span means 1/4 of total length. 1/4 of total length is 6 meter is there, 1.5 meter. Central span means half of the total length, 3 meter.
Okay, sir.
Okay. WL, what is the reaction? Tell me. See, 4.864 into 6 divided by 2. How much you'll get?
14.60.
14.6 kilonewton.
Yes, right answer. 14.6 kilonewton and 14.6 kilonewton. Now you find moment at support, quarter span and mid span. Okay, therefore M support, moment at support is equal to, what is moment at support? It is 0 only, right? Moment at support will be 0. 14.6 into 0 and the UDL not yet started. Okay, it will be 0 only always. Moment at mid span will be equal to 14.6 moment of that reactive force at center of the support. It is force is 14.6, perpendicular distance is 3 meter into 3 minus moment of this UDL about center. It is 4.864 into 3 into 3 divided by 2. From here to here, the length is 3. Convert this into point load. If you convert this into point load, 4.864 into 3, it will be a point load into perpendicular distance is 3 by 2. Answer? Or else you can directly take WL square by 8 formula also. No issue with that. You can find the moment by using reaction, or you can directly apply the formula of WL square by 8. What is the answer?
12.91 kilonewton meter.
12.91. 12 or 21?
21.21, sir.
21.91 kilonewton meter. 21.91 into 10 power 6 Newton millimeter. Similarly, you find moment at quarter span is equal to 14.6. Quarter span distance is 1.5 minus 4.864 into 1.5 into 1.5 divided by 2. Tell me the answer.
16.43
Yes,
kilonewton meter.
16.43 kilonewton meter. 16.43 into 10 power 6 Newton millimeter. Okay. Now write that formula. The formula is location of pressure line from the cable. Okay, that location is always with respect to the cable. From the cable, we will denote it as E bar is equal to M by P. E bar is equal to M by P, and this equation is applicable only for straight cable. In the bracket you write it. Equation is applicable only for straight cable. In the bracket you write it. Okay, if it is a parabolic cable, procedure is different. In the bracket you write it. Okay, now you go on finding location of the pressure line at each and every point. First at support, E support is equal to, it will be 0 only. Moment at support is 0. Moment at support is 0. It will be 0. Then E bar at quarter span you find. Quarter span is equal to, moment at quarter span is 16.43 into 10 power 6. 16.43 into 10 power 6 divided by the pre-stressing force is how much it is? 180.
180
right?
into 10 power 3.
Yes, into 10 power 3. So what's the location? What is the answer?
91.3 mm.
91.3 mm. Similarly, you find location of pressure line at midspan is equal to, corresponding moment at midspan is 21.91 into 10 power 6 divided by P is 180 into 10 power 3 is equal to how much?
121.66 mm.
1.72 mm.
Okay, 72 mm. Okay, now after getting location of pressure line at each and every point, you have to write the diagram accordingly. Okay, here I already written the diagram. Before copying, you just listen here. See, whatever the formula which we have, it is distance of pressure line from the cable. It is from the cable with respect to the cable. At support, distance of pressure line from the cable is 0. At here only at support. Okay, and I have marked midpoint, quarter span. At quarter span from the cable, distance of pressure line is how much? 91.3 mm. Okay, at quarter span, I have marked a distance of 91.3 mm. 1 point. Similarly, at center of the span, it is at a distance of 121.72 from the cable. Okay, similar in the same way, you will get points on other side of the beam. Finally, you join together, you will get a pressure line or thrust line. Write this diagram quickly. And note on the next problem also.
Sir,
Yes.
sir, if they have not given this exclusive of weight, what should be the procedure, sir? We should not consider this dead load.
If it is not given, then individually you have to find sulfate. If it is not given means exclusive of weight. If it is not given means, even if it is not given, then you find the sulfate. Okay, sulfate you add it. Okay.
Okay,
See
sir.
here in the
Okay, sir.
here in the second problem you see here deep supports UDL of 4 kN per meter, which includes the sulfate. Means sulfate is already included. Okay, then no need to find the sulfate. Okay, directly you find the moment for this load given. Okay, here
Okay.
it is said that exclusive, then you need to consider sulfate. Okay, if anything is not said, whether it is inclusive, whether it is exclusive, if anything is not said, then in that case also you find the sulfate and add to the line load and find the thing. Okay.
Okay.
Write the next problem also after writing the figure. Go on solving the problem. Okay, same procedure. Only the thing is sulfate you should not, you need not to find it, sulfate. Directly take the lay load of 4 kN per meter and locate the thrust line. So directly take this 4 kilonewton per meter, find corresponding moments and find eccentricity and draw the diagram. That's all. Shall we solve now? Here it will be 4 kilonewton. 4 kilonewton per meter. Here reaction will changes. What will be the reaction here? This will not come. 4 into 6 divided by 2. I think 12 it is, right? We'll get 12 kilonewton. All of you written the problem, right? Same procedure. Instead of 4.864 here, you have only 4 kilonewton per meter. Check your answers. What is moment at midspan? Anyone solved? Midspan moment. Tell me. Reaction is 12 kilonewton on either side. 12 kilonewton here also. 12 kilonewton. How much moment at midspan? Anyone?
18, sir.
18. Yes, it is 18. Correct. At quarter span also you find. It is 12 into 3 minus 4 into 3 into 3 by 2. You will get 18 kilonewton meter, which is 18 into 10 power 6 Newton millimeter. At quarter span it is 12 into 1.5 minus live load 4 into 1.5 into 1.5 divided by 2. Tell me the answer.
13.5, sir.
13.5. Here 13.5 into 10 power 6 Newton millimeter. Write the same formula. Here at quarter span 13.5 into 10 power 6. Then at mid span 18 into 10 power 6. Anyone got the answer? Tell me.
75 mm, sir.
70 is right answer. 75 mm. At midspan?
100, sir.
Yes, 100 mm. Write the figure. At quarter span, eccentricity is 75 mm. At midspan, eccentricity is 100 mm. After writing the figure, write the next problem. Try to solve this problem. Problem number 3. Instead of UDL, he has given a point load of 68 kilonewton. Follow the same principle. You find the reaction, you find on finding the moments at quarter span, mid span. Use the same formula. Same procedure you have to follow. Vaishnavi, are you writing? Vaishnavi. Sampath Kumar. Sampath Kumar. Sampath Kumar.
Yes, sir.
Writing?
Sir.
Ravi?
Sir.
Okay. Problem number 3.
Sir, question, sir.
Okay. Still writing, huh?
Yes, sir.
Write it. After finishing the question, you tell me. Okay, anyone of you tell me.
sir, completed.
Okay. A rectangular concrete beam, the cross section is given, a pre-stressing force is given, that is 540 kilonewton at a constant eccentricity of 60 mm. Eccentricity is given as 60 mm. Okay. Then 60 mm, the beam supports a concentrated load of 68 kilonewton. Earlier it was UDL, here it is point load, concentrated load of 68 kilonewton at center of the span of 3 meter. Okay. Determine the location of the pressure line at the center, quarter span, and support reactions, support sections of the beam. Okay, here it is asked to neglect the sulfate of the beam. So no need to find the sulfate. Whatever the load is given, directly take that load and find the location of the pressure thrust line or pressure line. Okay, write the corresponding figure. Write the corresponding figure. The beam having a span of 3 meter acted upon by a concentrated load of 68 kilonewton. Concentrated load of 68 kilonewton. Okay. The total span is given as 3 meter. 3 meter. Then in the problem it is asked to find the pressure line or locate pressure line at quarter span and at center span. Quarter span means how much it becomes? Length 3 by 4, 1/4 of 3, that is 0.75, right? And 1.5 meter, half of the length, 1.5 meter. First, find the reactions at the supports. Reactions at the support will be equal to reactions at the supports. Okay, it says symmetric loading, it is directly divided by 2, W by 2. VA equal to VB is equal to W by 2. 68 divided by 2, 34 kilonewton. So here you write the reaction of 34 kilonewton. Here also 34 kilonewton. Now you can find moment at support and mid span, right? As well as quarter span. Therefore, moment at support will be moment at support. How much? It will be 0. Okay. Then moment at quarter span. Quarter span means at 0.75 meter from support. So how much it is? 34 into perpendicular distance is 1.5 meter. Sorry, 0.75 meter. And there is no existing, there is no load existing, external load or live load existing between this span, only 34 into 0.75. How much? If you get any doubts, you can ask me. Huh? How much?
25.
Yes, 25.5 kilonewton meter. 25.5 into 10 power 6 Newton millimeter. Then moment at midspan. Okay. Moment at midspan will be moment of reactive force is 34 into perpendicular distance is 1.5 meter. 1.5 meter. Then minus 68 into perpendicular distance, it is 0. Why? The point lies in the line of action of force itself. So there is no perpendicular distance again here. 68 into 0. How much, students? Answer?
22.66.
22. I got 51.
51, sir.
Okay,
51.
51 kilonewton meter. 51 into 10 power 6.
Just calculating at support, sir.
Sorry?
How it is 68 into 0, sir?
See,
Point
here.
five.
No. You are calculating moment at midspan, right? Moment at midspan. Okay. Moment of this 34 kilonewton about midspan, midpoint becomes 34 into perpendicular distance 1.5 meter. Okay. Perpendicular distance of 34 kilonewton from midpoint is 1.5 meter. With respect to 68 kilonewton force, there is no perpendicular distance. Point lies in the line of action of force itself. 0 it is. For 34 you have the distance, perpendicular distance. For 68, point lies in the line of action of force, so there is no perpendicular distance. It is 0. Is that clear?
Yes, sir.
Or else if you have any confusion, directly apply WL by 4. Moment of concentrated force which is acting at the center of the span is always how much? WL by 4. If you calculate, you will get the same answer. But quarter span you have to follow this procedure only. Okay. Now find write that formula, eccentricity formula. That is location of pressure line formula. Location of pressure line from the cable E bar is equal to M by P. Okay. Now find the locations at corresponding points. That is E bar support is equal to 0. Moment is 0 because that's why it becomes 0. Quarter span is equal to quarter span moment is 25.5 into 10 power 6 divided by what is the pre-stressing force given? How much it is given pre-stressing force?
540.
540 into 10 power 3 in terms of Newton. Then midspan is equal to moment at midspan is 51 into 10 power 6 divided by 540 into 10 power 3. Tell me the answers. At quarter span?
47.22.
Yes. Millimeter. At midspan? How much?
90.44.
Yes, 94.44 mm. Okay. Now if you write the diagram with respect to the values obtained, so this will be the diagram. Okay. At support 0, at quarter span it will be at a distance of how much it is? Just a minute. 47. That whatever the formula is there, it is from the cable. From the cable it is how much? 47.22. From the cable, point is located at a distance of 47.22 mm. Okay. Similarly, at the center of the span, from the cable line, distance of pressure line is at a distance of 94.44 mm. Okay. You join all the points. Okay. From the neutral axis, if you want to find the answer, that will be 12.78. Okay. The total depth of the beam is given as 120. So half of depth is 60. 60 minus 47.2. If you do, you will get 12.78 mm. Sorry, this eccentricity is given as 60 mm. The cable eccentricity is given as 60 mm. 60 minus 47.2, if you do, you will get distance from the neutral axis. Even if you do not write this, no problem. If you don't get confused. From the
Sir?
cable line, yes.
Sir, is this thrush line is parabola or triangle they have given? We should join
It's
the
triangle.
points.
See, what is the nature of bending moment for the point force? It will be triangle, right?
Yes, sir, for
Nature
point
of
four.
bending moment for the triangle concentrate force, it will be triangle. So directly joined by a straight line. Okay, if it is a UDL, always the nature of bending moment will be parabolic.
Okay, sir.
Take the next problem after finishing the previous one. After finishing, write the problem number 4. Don't follow the previous procedure for this problem. Procedure is different. Kirti Kumar, are you there? Kirti Kumar. Not there. Nisarga.
Yes, sir.
Srikanta.
Yes, sir.
Okay. After finishing, tell me. Or
Yes, sir.
Yes, sir.
okay. A rectangular concrete beam 100 mm wide, 250 mm deep. Okay, 100 mm wide is there and 250 mm deep, spanning over 8 meter. The length of the beam is 8 meter. Is pre-stressed by a parabolic cable. Parabolic cable with pre-stressing force of 250 kilonewton. It is not the straight cable. It's a parabolic cable carrying a pre-stressing force of 250 kilonewton with zero eccentricity at the supports. Okay, the eccentricity at support is 0 and 40 mm at the mid span. Okay, 40 mm at the mid span. The beam supports a live load of 1.2 kilonewton per meter. Determine the position of the pressure line. Okay, as I told in the earlier, this formula is applicable only for straight cable. Okay, this formula is applicable only for straight cable. Here in this problem, yes. Here in this problem, he has given parabolic cable. Okay, we have to use. Yes. Any doubts? Huh?
Yeah.
Any doubts here? Okay, here parabolic cable is given, then the procedure is different. Then how to find the pressure line for a parabolic cable? Okay, beam carrying parabolic cable means, again you have to find resultant stresses at top fiber and bottom fiber. Okay, after that you have to look at centroid of the stress distribution diagrams. Okay, you have to find from the first principle by applying that formula. You have to find S superior and F inferior. Okay, that is the stresses at top fiber and bottom fiber. Then for each and individual figures you have to look at centroid. Finally, after joining, you will get the pressure line. Okay, let us solve this in detail so that you can understand. Time is 10:49 already. You first at this class you just write the given data P and A, I, Z. You find it. Then in the next class we will continue. Okay. I'll take the attendance.